Hello and welcome back to ACER Explained. In this series, I'm going through Section 3 of ACER's practice test booklet. In this video, I'm going through questions 28 to 31, so that's Unit 9. I'll be identifying prerequisite knowledge that you might need, reasoning skills that are used, and the bootcamp resources. Alright, so we're given an absorbance spectrum here for Unit 10, and we have different compounds that have different absorbance spectra. And we're assuming that unless, we're given any other information, the compounds don't react when they're mixed. So they remain their own compound. So they would have their own absorbance spectra. So then we're given question 28. We're given a spectrum and we have to figure out what mixture corresponds to this spectrum. So is it a mixture of 1 and 2, of 2 and 3, of 2 and 4, or 3 and 4? So in order to figure this out, we have to look at the different peaks that are appearing in this absorbance spectrum. So we have a peak at about 400 nanometers. Then we have another peak that is around, let's say, 470 nanometers. Then we have another one that's around, let's say, 670 nanometers as well. So we need two compounds that, when put together or when overlapping, would have peaks at all three of these sites. So looking at our compounds, the ones that have peaks at 400 are 1 and 4. Then the ones that have peaks at 470 are 3 and 2. And then finally, the ones at 670 are 2 and 4. Okay, so looking at our spectrum here, we also can notice that compared to the original spectrum that we're given in the stimulus, the peak at 670 is quite large. And so we can assume here or infer that there's likely going to be two compounds that both have a peak here that are overlapping, which results in this increased magnitude or increased peak proportional to the other two peaks, right? So right now we're thinking that 2 and 4 are likely contenders here. Now looking at 2 also explains the peak at 470. So that peak could correspond to compound number 2. Then we also have another peak at 400, and 4 could correspond to that peak as well. And so as we can see, these two compounds explain the spectrum quite well, and so that's why you would put C as your correct answer. So for this question, you didn't need any prerequisite knowledge. All you needed to know was how to interpret graphs and kind of infer information from those graphs. And the bootcamp resources that can help with this are the reasoning skills course as well as the acceleration class on graphs. So this question is asking us about a reaction. So it says one of the 4 compounds spontaneously converts into another one of those 4 compounds. And so if the absorbance at 500 nanometers increases as the reaction goes forward, then what would the reactant be? And that's very important to note, that it's asking us about the reactant. So basically, the two compounds that have a peak at 500 are compound 2 and compound 3. Okay, so you could potentially have compound 1 turn into compound 2. You could also have compound 4 turn into compound 2. However, if you had compound 3 turn into compound 2, then the peak at 500 would actually decrease. It wouldn't increase. Okay, because if you look at your graph that you're given, the peak for compound 3 at 500 is larger than the peak for compound 2. So we can't have this happening here. But you could have compound 1 turn into compound 3. You could have compound 2 also turn into compound 3, which would result in that peak becoming a little bit higher. And you could also have compound 4 turn into compound 3, right? So the reactant could be any one of these three. it can't be compound 3 because if it turns into anything else, the peak at 500 will either decrease or disappear. So out of the 4 options, the only one that can't occur can't be the reactant is compound 3. And therefore, D is the correct answer. Again, there was no prerequisite knowledge required. It's all about just interpreting the graphs and being able to identify that information. And that's the same resources that I mentioned earlier for the previous question. So in question 30, we're given another graph. So we're given absorbance spectra of products and reactants of a reaction. And we're basically asked which of the following 4 options is best supported by this graph. So we're going to start off by just doing the process of elimination. So just for some context, we're going to look at the solid line, which is products. And with the products, there's a peak at around 400 nanometers. There's a peak at around 470 nanometers. And that's all for the products. Then we have the reactants, which is the dashed line. And so with the dashed line, we have a peak at 400 nanometers. Then we have a little peak at 470 nanometers. And we have a big peak at around 670 nanometers. So given that, let's look at our answer options. So answer option A says that compound 3 and 4 are the reactants, and 1 and 2 are the products. So let's look at the stimulus, 3 and 4. So 3 is the pink dotted line, and 4 is the blue line. So with the blue line, we have a peak at 400. So I'm going to say for number 4, we have a peak at 400. We have another peak at 670. And then for the pink dotted line, so for compound number 3, there is a peak at around 470. All right. And so this is reactants. Now we have to look at whether this matches up. So with our reactants, we have a peak at 400, a peak at 470, and a peak at 670. So this could make sense, okay? But let's look at the products. So we have 1 and 2. So we have 1 and 2 being the products. And so with 1, we have a peak at 400. And for 2, we have a peak at 470. And another peak at 670 nanometers. And this doesn't actually go with what we have here with our products, because with the actual spectrum that we're given, there's only a peak at 400 and 470 for the products. So we can eliminate this option. Now looking at option B, we have 2 and 4. So let's look at 2 and 4 in terms of the reactants. So compound 2, we have a peak at 470. Then we have another peak at 670. Compound 4, we have a peak at 400. And we have another peak at 670. And now this adds up because we have a peak here at 400, 1 at 470, and then here we have 2 at 670, which kind of corresponds with the fact that this peak is quite large at 670. So that makes sense. So let's look at our products. So we have 1 and 3 being the products. So compound 1 has a peak at 400, and compound 3 has a peak at around 470. And that adds up as well. So we can confidently say that B is the correct answer. And then you'd basically go through and eliminate the other options if you were unsure. But yeah, the answer is B. And this is the same as before, no previous knowledge required. The reasoning skills that you used were interpreting graphs, and the bootcamp resources are the same as before as well. So this final question is a little bit different. It's basically saying that if you have a mixture of compounds 1 and 3, and each of these compounds contributes equally to the absorbance at 480 nanometers, what would be the proportion of each compound within this mixture? So what we have to look at first is look at the 480 nanometer mark. So looking at our stimulus, at 480 nanometers, we have quite a tall peak for compound 3. So that's the pink dotted line. All right. So let's say that this is 480 here. And then we have our y-axis here, absorbance. And wavelength in nanometers. And if we look at compound 1, our compound 1 is going kind of like this, okay? And so looking carefully, over here, this is around 0.8 units in terms of absorbance. And then over here, we have kind of this line going up here, which is 0.2, and at 480 nanometers, that's approximately 0.1 units of absorbance. So in order to contribute equally, you would need 8 times as much of this compared to this, right? So if you have 8 times as much of compound 1, then that's when you would reach this kind of level here. And so that's why the answer is D, right? And even if you couldn't kind of come to this conclusion about, the more of a particular substance you have, the more it would contribute to the absorbance at a particular wavelength. Even if you didn't come to that conclusion, you can see a trend here. You have 0.1 for compound 3, compound 1, and you have 0.8 for compound 3. Right? And so there is a relationship here that's represented by one of our 4 answer options, and that's multiplying it by 8. And so you could guess D as the correct answer option as well. Again, no previous knowledge was required. All you needed to be able to do was interpret graphs and also kind of come to that conclusion in terms of the relationship between those 2 compounds. Like I said earlier, you didn't need to actually fully understand the concept of having more of a particular compound would result in more absorbance at that particular wavelength. If you can see the relationship between numbers and you can see that represented in one of your answer options, then that's evidence enough for you to be able to select that option and move on, especially with the interest of time in mind in the actual GAMSAT. And that brings us to the end of Unit 9. Thank you so much for following along. Please like, share, and subscribe for more GAMSAT help. We really appreciate your feedback. We have our Instagram here at Thank Flip GAMSAT and our podcast, Thank Flip GAMSAT, Nurses Doing GAMSAT, if you want to hear more from us. All right, I'll see you in the next one.